Alright, this is a very short video just showing how you can place pickups on the terrain. So you can see if I play it now, I've just got a ball, control it around, nothing fancy here, I've got some trees. You can't see any of the pickups. Now the reason for this is I've placed them all at the same height. So actually if I play the game and double click on one of the pickups, you can see there it is. You can see over here its location is Y is at 15. 15, 15. So most of these are appearing below the terrain. Some are above the terrain because my terrain, if I zoom out or pan around, it's got quite a large hilly section in it, which means if I place it at 15, and some places, if I drew a line through here, some of them will be above the terrain, but as I go across to here, these guys will be below the terrain. So using a static number doesn't really work. So what we need to do is code it up in such a way that this Y value changes depending on the height of the terrain. It's quite simple to do. So what I've got here is I've made a pickup manager which is sitting inside my room, and I've put the pickup in here. This variable here is just so I can easily change how far above the ground I want it to be, and down here I've got a loop which generates 1000 pickups. Each case my terrain's 1000 by 1000, so I'm generating a number which is between 0 and 1000. That'll be the X position and the Z position, and this piece of code here instantiates it. So I'm instantiating a pickup which is referenced here at this location, which is a new vector 3, so there's the X position, the Y position, and the height is hard coded at 15. This just means that the rotation is the base rotation. Now all I've done is I've created a new function down here which I've called calculate height. And into that I'm passing the X position and the Z position. Sorry. X position and the Z position. And this function is going to return a float. So once again, X position here goes into X position here, Z position goes into Z position here. Now I'm using a raycast. What a raycast does is it draws a line from the starting position in this direction and then returns the point where it hits something. So in this case we're hitting the terrain. If you had other things in your world you might have to get a bit fancier, but for mine it's the only thing that's going to be below that point is the terrain. So anyway, so this is the position that we're starting that raycast at. So let's say hypothetically it was at this randomly generated 100, 100. So if I go back to the world just to demonstrate, I'm just going to Alright, so we'll zoom in on my player. Okay, I'm just going to create a new cube for now, just demonstrate this. If I put this cube at 100, 100, and I'm going to start it at, put it at 100, and I go to look at the cube, this is where the cube starts. So in this example of the code, we're starting at 100 because that's what we passed in. If it was randomly generated 100 there. We're starting at a height of 100 and a Z position of 100. So where this cube sits is where that raycasting would start. And from that point it would draw a line down until it hits the terrain. Okay, so if I kept, basically if I kept dropping this number, alright, eventually at that point there, wherever that is, about 61, it's going to hit the terrain. So in the code, that's what would be come out of hit. So what we're doing here is returning hit dot point. Point is the point it hits the terrain, and all we need is the Y value. We don't care about the X and the Z position because we know those because we've passed those over. So all we care about is the Y position, and then we're adding to it this space above ground. That's just how far above the ground we want it to be. Alright, if I made this 0, so I'm just returning 0, so all it's doing is going to return the point actually collides with the terrain. If I go back to my game and we look at these you can see that they're halfway through the terrain, which is not ideal. So we are calculating the point where it hits the terrain, but we want to go slightly above the terrain to make it a bit more useful. You can see down here that pickup is actually slightly below the ground, which is not perfect. So all we have to do then is go back to the code and we'll just add back in what we had there. Now if we run it again, you can see as I move around, it's slightly above the ground. You can tweak that number. Actually, you can tweak that number. There you go, and I can pick it up. Well, that's all that's required. So that's the piece of code there. So once again, I've just made a function that raycast, which is basically draws a line from a point we specify in a direction we specify, and outputs all the information about when it hits something. In this case, all we care about is the point that it hits and the y value within that point, and we're returning that. Cool.